everybody. Today I'm going to be talking with y'all about testing rocks and minerals. So the common tests that we do and how we can distinguish different types of minerals from other types. So common tests that we'll look at today are hardness. So how hard is the mineral or rock? Color, streak, luster, cleavage, and then some special properties. So hardness is determined by Mohs hardness scale. This was created back in 1822, and it's a scale from 1 to 10, where 1 is the softest, that would be something like talc, and 10 is the hardest, which is diamond. So here is a figure looking at the different scale numbers. So with some different minerals here, 10 being diamond, all the way down to talc, and also comparing it to a common object. So we can determine the hardness of a mineral or a rock using common objects. So if we know that something is scratched by your fingernail, but it's not scratched by a penny, we know it's between 2.5 and 3.5 on this scale. So that's why they included some common objects here. Great. Our next test is color. So this is just color that you see when you look at a mineral or rock. Some minerals and rocks are easily recognizable by their color, but others come in a variety of colors. So color isn't always the best judge to figure out what a rock or mineral is. Over here I have sulfur. Sulfur is a bright yellow. There's not really any other minerals that could be confused with sulfur, so sulfur is a good one to use color to identify. But here are some different examples of quartz. We've got some amethyst and some clear quartz and some smoky quartz, so lots of different colors. So I wouldn't stop at color to identify something as quartz. Streak is similar to color, but it's the color of the mineral powder. So we determine this by grinding a sample across a porcelain plate, and you can see what color the powder is, and that doesn't have as much variation as the color of the mineral itself. So this is more accurate than just observing the color. So here you can see there's 4 different samples, and they each have very distinct, I guess those two are kind of similar, but pretty distinct different colors for their streak, the powder that they leave behind. Another characteristic that we can use to identify a mineral or a rock is luster. So metallic, that one's pretty self-explanatory, it's shiny like metal. And then non-metallic has a bunch of different classifications. These are just a few. So here's something that's obviously metallic. Here's something that's glassy. It appears to look like glass. Here's something that I would probably describe as waxy or greasy. Looks almost kind of wet. And then here's a sample that would be earthy. So it looks kind of soily, but it's more of like a rough brown kind of not shiny material. Right. We can also look at the cleavage of a sample. So does the sample break cleanly along planes? That's called cleavage, or fracture irregularly. So this is similar to crystal structure. So if something breaks at a certain angle, it has 2 different cleavage planes that come together. Some minerals like mica comes in sheets, really, really thin sheets. Other minerals don't cleave at all. They just fracture roughly. So that's another good indicator of what kind of mineral we're dealing with. Okay, so then there are some special properties. It's not an extensive list, but it's some common special properties that you can look at. So you can determine if the mineral contains calcium carbonate by dropping it or dropping some weak acid on the sample. So some weak hydrochloric acid, if you drop that on the sample. If it fizzes, it contains a significant amount of calcium carbonate. Is the sample attracted to magnets? When you look through the sample, does it cause any sort of refraction? You can measure the specific gravity, and you can test to see if it's fluorescent. So does it react under a UV light? So here's an example of a sample that has an acid solution being dropped onto it, and it is fizzing, indicating it contains calcium carbonate. I think this is a sample of limestone. And here's an example of something that causes a refraction. This is a sample of calcite, as it says. It's actually pretty cool. This double image is called birefraction, and it's caused because calcite has different indices of refraction based off of what axis, what optical axis you're looking through. So it causes this double refraction, which is pretty cool. All right, so we can also use what we know about types of rocks to give us information if we're looking at a sample of a rock rather than a mineral. And other people are going into much more detail about the types of rocks. So just real quick, if we're given a rock and we're trying to identify what it is, we can use those mineral tests. But we can also look at the types of crystals something has. So igneous, we know, is formed from lava or magma. We can break it down into an intrusive or extrusive type of rock. So based off of larger crystals or smaller crystals, potentially glassy like obsidian, or vesicular with little essentially gas bubble holes because it cooled so quickly. Metamorphic, that's been changed by high temperatures or pressure. You can identify metamorphic rocks sometimes if they're foliated, so if there's layers of minerals versus non-foliated. And then sedimentary, you'll be able to see the grains of sediment. And sometimes you'll see those as being layered. So here's an intrusive versus extrusive rock, a foliated versus non-foliated metamorphic rock. And then here is a sample of a sedimentary rock where you can see those layers. And if you were to feel this, it would feel very sandy. You can feel those individual grains. All right, so let's do an example. Let's identify what this mineral is. So I'm going to give you a couple of extra properties besides what we can see in the picture. So we can see, obviously, it looks to be green, and it has some pretty clear cleavage. It looks like it has kind of a cubic shape. Other information I'll give you is that it can be scratched by a knife, but not a penny. So if you look back at Mohs hardness scale, that would be between, and let me switch that actually. It's scratched by a penny, but not a knife. So sorry, flip that. So that means it's between like 3.5 and 5.5 on the Mohs hardness scale. Let's say we took this across a streak plate and it left a white streak. So the powder of this mineral is white. And the luster is vitreous or glassy. And I use vitreous just because the chart I'm going to show you uses that word instead of glassy. So let's go over to this big table. So this table, there's a lot of different mineral identification tables, but this is just the one I found that was useful for me. So we've got two different tables. Minerals with metallic to submetallic luster. So if you know that you have a metallic sample, use this top table. We don't have a metallic sample, so I'm going to go down here. The hardness is this first table, so that's how they have this organized. So I'm going to go down here to look between like 3.5 and 5.5 because I know it's scratched by a penny, but not a knife. Flip that. I don't know why I keep doing that backwards. All right, so we know the color is green. Okay. So it looks like potentially it could be malachite or fluorite or apatite. Okay. So narrowed it down to a few. Then I would look at the streak. And I know the streak is white, so that kind of kicks malachite out of the options, and it's either fluorite or apatite. Both of those are glassy. But then if we look over here to cleavage, fluorite is cleaves in 4 directions, and apatite does not. If I look over here, this is just some more information in the last column. Cubic crystals are common, 8-sided diamond-shaped crystals, and often fluorescent. We don't have information about that, but I would say with that information, I would identify this as fluorite. And we would be right. Awesome. So thank you guys. That's all I have for you.